Okay, for this lesson, what we are going to be doing, sorry about being on the wrong page there when we started, is the formal name of it is Analyzing Functions with Successive Differences. So if I unpack that so that it sounds like English and not just weird algebra mumbo jumbo, what that means is we are going to look at different functions and see if we can determine quick and easy differences between them so that when we're looking at an equation of something or at some data that shows something, ordered pairs, a table, something like that, we can look at that and say, oh, this is an exponential function, this is a quadratic function, this is a linear function, and those are the three different kinds of functions we're going to talk about. So and with successive differences, they just mean that when they're giving you ordered pairs or giving you tables or any of that, you're looking at it as it goes up successively. So kind of, you look at an x at a y value when x is -2, and then when it's -1, then when it's 0. So it's not jumping all over the place. And that's what successive means, things following each other. So in order to get a good grasp on this, we first have to talk about exponential functions. And I don't believe we've really gotten into those much this year. It might have been something that we skipped over. Otherwise, if you're watching this another year after this is made, because I hope this video gets used for more than just now, I think the best way to describe what an exponential function is it's something that grows really quickly over a very short period of time, and it appears to have end behavior that moves towards something. So it's similar to a quadratic, but they grow a lot faster when they start to turn than a quadratic, and you'll see what I mean once we do a couple of these. So what we're going to do is we're going to look at some tables of this. This is our general form, is y equals a b to the x, or more often than not, honestly, you're going to probably just see something like this where you don't have an extra coefficient out in front, where it's just y equals b to the x. So, and b is always going to be a positive, basically a positive integer, so something greater than 1. All right. You'll see something once you get into Algebra 2 that is called the exponential function, and you'll see these things, these y equals e to the x, where e is a constant. I think it's like 2.17. I don't know. I'm guessing, but it's sort of like pi, but it's its own thing. It's called e. And so we're going to look at what these functions kind of look like on a graph, and in order to do that, we're going to do a table first. All right, so we're going to look at two different ones. We're going to look at y equals 3 to the x power. So what that means, all right, is you've got your x values and then your y values. What you get out, whatever you put in for x actually gets put as the exponent. You're not used to seeing that. You're used to seeing something where you have x and then it gets acted on by an exponent like 3, or maybe it's x squared or whatever it is. You're not used to seeing this thing where it can change depending on what the x value is. So that makes these things really kind of wild. So if I put 0 in, what that means is you have 3 to the 0 power. Anything to the 0 power is 1. All right? If you put 1 in, you get 3 to the 1 power, which is 3. You put 2 in, you get 3 to the second power, so 3 times 3 is 9. And then you can see that this thing grows really quickly, like really quickly. But what's really interesting about these is what happens when you have negative x values. So if I put in -1, right, you have 3 to the -1 power, which is the same as 1 over 3 to the 1, which is 1/3. All right, so you've got something that's like, 0.33, right, and it's positive. If you put -2 in, it's the same thing. You're going to get 1 over 3 to the 2 power, because that's the same as 3 to the -2. And that's 1/9, and then that gives you, that's, 0.11 repeating, right? And then as you keep going, as the negative numbers get smaller and smaller, you get this number that gets closer and closer and closer, and it heads towards 0. So it's really interesting. So you wind up, all your negative values wind up being really close to 0. They do change, but they wind up being really close to it. And you'll see what I mean by really close to it when I graph this thing later. All right, so this is kind of like your basic exponential function. Let's look at this next thing over here just to kind of see like what happens if you do have a coefficient acting on it. So we're going to start with the same thing. So I'm going to do this in 2 stages. So we're going to go x, and we're going to say what's 2 to the x, and then what's 3 times 2 to the x. So making just a basic function table here. Well, if I put 0 in, anything to 0 power is 1, and then 1 times 3, right, because it's this times that, is 3. And then if you put 1 in, 2 to the 1 power is 2. And then 2 times 3 is 6. So whatever you get in this column, once this column right here is going to take it and just multiply it by 3. So it just triples everything. You put 2 in, you get 4, and then that's going to give you 12. You put 3 in, 2 to the third is 8. And that is going to give you 24, right? So it's going to open up really quickly again, but it's going to open up 3 times as fast, right? It's going to cover a lot more ground in a shorter period of time. Now, if I put negative numbers in, it's going to be the same thing. You're going to have 1 over 2, which is 1/2, right? You multiply that by 3, you get 3/2, right? If you put negative 2 in, right, you would get 1 over 2 squared, which is 1/4. You multiply that by 3, you get 3/4. And you'll see that even though we're multiplying it by 3, this number is going to get closer and closer and closer to 0, just like this one. So very similar. They just sort of, this one sort of grows a lot more quickly in the positive direction. So let's take these and let's look at Desmos really quick. And let's see. Hopefully this will let me do this here. Yeah, I think you're still with me. All right, so we're going to put in y equals 3 to the x so you guys can see what this looks like. All right, so got this thing here that this was our 1 right here, and then it grows very quickly, all right? And then what you'll notice is that if I take this and I move it up, right, and I kind of pan out, is that it continues to move to the right. It continues to grow. But it grows really, it seems like the x values, you know, like there's a part of me that says, well, if you put 20 in, you know, it doesn't work. Like it should stop somewhere. But it's just going to give you an enormous value. And if you pull this out more and more, you'll see that eventually 20, you know, right now is like over, you know, here. And it will eventually get everywhere. It's just as it approaches infinity, right? So let's get this back kind of to here. And then the other interesting end behavior I want to show you is what happens as x approaches negative infinity. It sure looks like this is on 0, right? But what happens is if we pan out and we keep looking at this, you'll see that no, it never really quite touches 0. It gets really close, you know, go on, and it's like, okay, well, surely it's on 0 now. But if I pan in, no, it's not, right? And so that's the way it is. I can do this all the way out to negative infinity, and it will never touch 0. It'll get really close. And for practical purposes, it becomes 0. But in theory, it's not 0. All right, so let's look at that other one. So we're going to leave this one here. So let's take this and let's make this y equals 3 times, and then let's make this 3 to the x so we can compare the same function, what happens to it. And so I've done this now. Let me see here. And so let's see. It's being weird. So the green is the new one. So you can see it's kind of the same thing, you know. It's y-intercept is higher because you're multiplying it by 3 and everything, but it follows basically almost the same kind of, you know, arc, right? So, and then it just takes a little longer to get closer to 0 than the blue line, but eventually, you can see it will probably always be just 3 times bigger than the blue. And if you got something that's like 1 millionth, well, it would be 3 millionths then. So it's still really, really tiny, but it's just enough bigger than the blue where that green line is always going to be on top. So those are exponential functions. They're kind of cool, I think. And they're really interesting, but they're a model for growth that is used for a lot of things. They're a lot more practical than a parabola, a quadratic, and yeah, and they're used a lot in modeling real world situations with like water flow and diseases and things like that. So very interesting stuff. All right, we're gonna stop this video and then we'll move on to the next one.